This course is the Economics of Zero Energy Homes, Single Family Insights, a report from the Rocky Mountain Institute. This course is brought to you by the nonprofit, the Green Home Institute, and today I will be your moderator. My name is Brett Little, and I'm the Executive Director here at the Green Home Institute. The course is approved for 1 hour in continuing education units, GBCI, AIBD, NARI Green, Certified Green Professional, BPI, Non-Whole House, as well as AIA, Health, Welfare, and Safety, which may make it applicable to your state-based design or contractor license. Make sure to check out our upcoming courses. Next week, we've got Duct Optimization and Performance, Introduction to Fully Ducted Heat Pumps and All-Electric Heating and Cooling, Building Clean, the Benefits of Buying Local, Building Healthy, Energy-Efficient Products Database. We have local events in Grand Rapids, our second ever Building Green and Beer series on going all electric, and then we've got urban forestry coming up as well for the end of the year. Become a member today, support our mission, help keep these sessions going, and get instant registration and access to all of the courses. Huge thanks to our session sponsor today, GeoComfort Geothermal, helping many across the country live a net zero or zero energy life. And they've got all sorts of products. They've got a new in-floor radiant that can also be utilized for water heating. And so water heating, and then putting in the cooling ducts as well. And believe it or not, but there is a 30% tax credit for ground source heat pumps that is still available until 2021. And then a big thanks to our main session sponsor, T-Stud. T-Stud is a simple concept, a thermally broken insulated wall stud assembly for use in exterior walls and party walls, made right in Minnesota. The T-Stud is a new building product that uses 2 machine stress rated MSR or number 2 lumber members as an internal truss system and a frost in place closed cell foam. These extremely straight uniform studs make square construction a breeze. Conventional 2x6 lumber needs a 5 to 12% call rate to avoid bowed, warped, and cupped boards. Using T-Stud, the call rate is virtually zero. 2x8 is underway as well. Based on some initial testing, a 4 to 7 point drop in the HERS index rating in an energy efficient over standard 2x6 wall construction, nearly as efficient as continuous insulation for an estimated 1/4 of the cost less. The T-Stud wall assembly comprises of all the members needed to build an exterior or interior wall and has been tested by United States Gypsum for soundproofing. Wall assembly provided as a sound transmission class rating of a +6, which is equivalent to a wall being constructed with a resilient channel on both sides of the wall. Providing 90% improvement in noise control over 2x6 framing can be used for the interior walls around bathrooms or laundry rooms. Head over to tstud.com today to learn more. Well, I'm very excited to be continuing our conversation about how we get homes and buildings to zero energy and what barriers still exist to get there and whether it's economical to do it. And so anytime we can help you all learn more and have us learn more about how to knock these barriers down, we're just thrilled to do that. And so I'm excited to have some great folks from the Rocky Mountain Institute here to be going over a report that they just recently put out there and have them back again. So our first speaker is going to be, or our second speaker is going to be Michael Gartman. He's a senior associate at the Rocky Mountain Institute's building team. Michael utilizes a background in statistical analysis and energy modeling to develop analytical tools geared toward informing and facilitating real estate portfolio optimization strategies, synthesizing the deployment of energy efficiency and renewable energy projects over time and space. He brings a diverse range of expertise in the construction industry to RMI's building practices. His past work has included cost estimating commercial solar installations and advising the County of San Diego on the Sustainable Energy Plan, drafting legislation for PV-friendly permitting and installation standards, and constructing steel cable pedestrian bridges in rural Bolivia. And then Alicia Peterson is a senior associate on Rocky Mountain Institute's building team, where she focuses on breaking down barriers to increasing market penetration of zero energy buildings in both the residential and commercial sector. Prior to joining RMI, Alicia worked over at our friend's Seventh Wave, where she served as an energy engineer and project manager and provided technical assistance to building owners and design teams to help inform a more energy efficient building design. All right, so with that, Alicia, I will hand it off to you. And again, huge thanks to you all in RMI for joining us again.
Right. So first, I'll give an overview of Rocky Mountain Institute, or RMI. We're to create a clean, prosperous, and secure low-carbon future. We're to kind of have this mission become a reality. We've been growing pretty quickly. We actually have 190 full-time employees now, and this was just in the last month we've added 20 new employees. So we're growing fast. We work in the building sector, the transportation sector, as well as the electricity sector to kind of tackle the energy problem on all different angles. We have offices in 5 different locations, including Basalt, Boulder, New York City, Washington, D.C., and Beijing. So thanks for the opportunity to present our findings on the economics of zero-energy homes. Today, we're going to start off by giving just a little bit of background on why zero-energy homes are needed, the current cost of zero-energy homes, what goes into the technical solution for zero-energy homes, how we expect costs to decline over time, and then how we can scale these results so that we can actually see greater market penetration of zero-energy homes. So I think this slide gives a pretty good overview of what's wrong with zero-energy homes today. If you can tell, the slide's pretty difficult to read. It looks really fancy, it's green, but it doesn't feel very approachable. And I think to date, that's kind of how zero-energy homes have been approached, where people see them as only attainable for kind of the select few that are rich and wealthy enough to pay for a more expensive home to do what's right for the environment. And as long as zero-energy homes have this kind of reputation, we're never going to see greater market penetration. So our research and this report was really to try to transform zero-energy homes from this into this, which is, zero-energy homes, very basic, very approachable, Arial font. No one's afraid of Arial font. And so let me start by just defining what a zero-energy home is. We're defining it as a home that produces as much renewable energy over the course of a year as it uses. And so essentially, it's a really efficient home with solar PV on the roof. There are many different definitions of zero energy, many different terms for zero energy, net zero energy, zero carbon, but we chose to do this zero energy homes as the kind of definition here because we're aligning with the Zero Energy Ready Homes program that the Department of Energy runs. So to date, we see about a little bit less than 2% of the new construction residential market is zero energy homes. So it's a very niche market. But single family homes make up over 40% of the total carbon that's produced by buildings and building stock. So we kind of focused on single family new construction homes in this report because we felt like this was a great intervention point to approach zero energy. And kind of our hope is that through this research, we can kind of make the case that all new construction homes should be built to zero energy or zero energy ready standards. The reason we feel like new construction is the right place to think about this is any home that's being built right now is going to be around for a long time. And even just the components within the home, like the HVAC system, the appliances, those are all going to be around in 2030, which is when a lot of cities have set their climate goals to meet a certain level of efficiency. So building it right the first time is really important. Also, when you're building it for the first time for new construction, you're able to get the benefit of just needing to account for just incremental cost. When you're doing a retrofit scenario, like let's say you're talking about retrofitting your windows, you need to then justify the entire cost of the windows and the entire cost of labor. Whereas in a new construction, the labor for installing high performance windows over typical windows, there's no real difference there. And then you really only need to account for the incremental material cost. So from an economic standpoint, doing zero energy homes in new construction makes a lot of sense. There are also just a lot of benefits to various stakeholders for approaching zero energy homes. I already kind of touched lightly on the climate action plan that many cities have, but in general for the community, building new homes to be zero energy is going to be to get you closer to that climate action plan. It future-proofs your housing. It makes it more, it improves your housing stock. For builders that are building zero energy homes, this is kind of a way to differentiate your offering, especially because right now it's such a niche. If you are able to build a high quality zero energy home, you're kind of a unique builder and you can get at a different market. For consumers, they're able to reside in a more comfortable home with better indoor air quality that's more durable with a lower energy bill. And then for utilities, pretty much we're kind of, this is sort of the path that needs to happen in the future. And so utilities can jump on board and figure out how they can use these homes to create a more resilient grid, create new business models. And so overall, zero energy homes are a win for all stakeholders. So now I'm going to give a quick overview of what the current cost of zero energy and zero energy ready homes are. So what we did was we did a technical analysis in 4 different cities. And you can see the results here that for a zero energy ready home, which I don't think I defined, a zero energy ready home is essentially a zero energy home just without the solar PV on the roof. So a zero energy ready home is seeing less than a 3% incremental cost in general, and a zero energy home is seeing less than 8% incremental cost. So this is a lot lower than I think most consumers or builders or policymakers realize. There was a report out just a few months ago. It was an article that was saying, would you be willing to pay 40% more for a zero energy home? And as long as articles like that are coming out, there's going to be this barrier to entry. And I think seeing that the incremental cost isn't nearly as much as people think is one of the first steps in kind of breaking down that cost barrier. So I want to give a quick overview of our analysis process. What we did was we created a prototype building that's based on kind of a typical single-family home, looking at the census data to determine what's a typical home. And that's about 2,200 square feet. It's 2 floors, 3 bedrooms, 2 baths. There's a garage. And then we used IECC 2009, that energy code, to determine the envelope properties and the HVAC efficiency and air leakage and all that. The reason we selected IECC 2009 was because that's typically kind of the most common, if you look across the United States, that's the most common energy code. And for most cities that have energy codes that are not IECC 2009, they're actually more aggressive, like 2012 or 2015. And so this is really taking a conservative approach, because if the incremental cost from IECC 2009 was $5,000, potentially if it's 2015 IECC that has a stricter code, the incremental cost will be $3,000 or something along those lines. We selected 4 cities that represented 4 different climate zones, climate zone 2, 3, 4, and 5. And the reason we selected only those 4 was 90% of homes, new construction homes, are being built in those 4 climate zones in the US. And but I do want to just add the caveat in, which is if you're in climate zone 1, 6, 7, or 8, there might be a different technical solution because, for instance, like heat pumps don't necessarily operate as well in colder climates or like those really extremely cold climates as they do in the climate zones that we selected. So we did use VOPT, which is a free software from NREL called, and it's VOPT is Building Energy Optimization. And essentially, it takes a bunch of energy efficiency measures. There is a cost database built into VOPT. And we looked at that cost database and updated it with 5 trusted other cost sources to make sure that we felt comfortable with the costs that we were using. And then it runs an optimization to determine what's the lowest cost it takes to get to net zero energy. And so I think that's really good to emphasize. We weren't focused on, cool factor or, what's best for indoor air quality. We are really focused on what's the most cost-effective way to get to zero energy ready or zero energy. And so then once we had these incremental costs, we wanted to kind of gut check them in reality. So like I said, the zero energy ready was about a 3% incremental cost or less than 3%. The zero energy was less than 8%. But what does that mean in terms of what customers or what the market is willing to bear? So we compared this cost against 4 different consumer thresholds. The first one is the mortgage threshold, which is, does the net present value of all the energy savings over the course of the mortgage exceed the incremental cost that was paid for the zero energy home? And this threshold is really, it's a great threshold for those long-term thinkers, but a lot of your average consumer is probably not planning on staying in their home for 30 years. So the next threshold we looked at was the resale threshold, which is looking at a typical length the homeowner stays in their home, which is 12 years according to, according to the realtors, some realtor resource. Does the energy savings over the course of those 12 years exceed the incremental cost of a zero energy home? And this is, again, it's more for the long-term thinker because you would need to, you would only kind of pay back after 12 years. The next threshold was based on consumer research. We found 3 different research studies that said at about a 4% incremental cost, 50% of consumers are willing to pay more for a net zero energy home. And so this is the first threshold where we're really starting to see pretty good market penetration. If a home can hit this 4% threshold, 50% of consumers are willing to pay more. And then finally, it's the zero first cost threshold, which shows that if the zero energy home costs the exact same as a standard code baseline home, then essentially we've completely eliminated the cost barrier. And in theory, if cost is the only concern, 100% of consumers would be willing to buy a zero energy home. So first, I'm going to show how zero energy homes compare against these various cost thresholds. This is a somewhat complex plot, so let me just kind of walk you through it. The arrow with the key is the mortgage threshold, and the people shaking hands is the resale threshold. The icon with the little people in it is the consumer willingness to pay threshold, and then the thumbs up is the first cost threshold. The blue bar is the current incremental cost for a zero energy home. When the blue bar falls below the threshold, that means that threshold has been achieved. So what you can see is that in all 4 scenarios modeled, the mortgage threshold is not only achieved, it's significantly achieved. We're almost halfway less than what the mortgage threshold is. The resale threshold is achieved in Baltimore and super close to being achieved in Atlanta and Chicago, and relatively close in Houston. there's a little ways to go for the consumer willingness to pay threshold to be achieved, and then the first cost is, still a ways away. Two things to point out, though, is our analysis didn't account for local incentives. And that was just because local incentives are complicated and constantly changing and vary significantly by location. So we didn't want to account for those in our analysis if they were going to be going away, or, just kind of, again, to be conservative, we didn't account for them. So that being said, if Atlanta or Chicago had incentives, and I know for a fact Chicago has pretty good incentives for single-family new construction, the resale threshold would be achieved in those locations. The other thing to account for is in this zero energy homes model, we assume that solar PV was being financed, or it was not being financed, so it was being purchased outright. If a PPA or a solar lease was being accounted for, the economics might actually look a lot more similar to this zero energy ready homes threshold. So again, the same icons. Now that blue bar is the incremental cost of a zero energy ready home. And you can see this is pretty exciting. We've achieved the mortgage threshold. We've consistently achieved the resale threshold, and we've achieved that consumer willingness to pay threshold. And in some locations, we're less than 2% away from achieving that first cost threshold. So again, potentially, depending on local incentives, we could be really close to cost parity, which is extremely exciting. But I think the more exciting thing to emphasize is we achieved this consumer willingness to pay threshold, and we handily achieved that. And what that tells us is that 50% of consumers are willing to pay this incremental cost for a zero energy ready home. And like I said, right now, only about 2% of the new construction residential market is zero energy or zero energy ready. So that means there's this wide gap between how many consumers want this product and how many builders are actually building this product. And so I see this as a huge opportunity for builders that want to differentiate their market offering and get a bunch of new customers that are interested in a more efficient building. So at this point, I'm going to pass it over to Michael, and he'll talk a little bit more through our technical solution.
Thank you very much, Elisa. All right, let's jump into it. First off, let's just cover this really quickly. I can't actually remember which of our 4 locations this was, but just giving a general sense of how efficient of a building we're talking about. It's about 50% more efficient than, again, that IECC 2009 code baseline. Obviously going to vary a little bit between location, but that gives you a general sense of the level of efficiency we're looking at, and thus the level of solar. So let's jump through 5 of the really essential pieces or results really that came out of our analysis. First, heat pump heating and cooling systems. Really an exciting thing. We're looking at actually ductless mini splits in all 4 of our locations. That was the recommended system. A few things to hit here. One, and this is going to apply to a couple other things, but this heating and cooling system is necessary for electrification. Couple of things to note there. Some definitions of net zero energy require electrification. There's also just the fact that electrification and a huge push towards that is going to be really necessary to achieve our climate goals. I was actually just listening to a coworker talk near the water cooler a couple of days ago about some rough analysis that they did. I think looking at the pathway charted out in that recent and very depressing IPCC report, and figured out essentially that we need to peak natural gas consumption in 2020 to achieve those goals. So that is extremely ambitious, and we need to be doing everything that we absolutely can. Then heat pumps, they're a lower cost option in a lot of situations. This isn't just because it's a combined heating and cooling system in one system. That is a nice little simplification. There's also you have an opportunity to have either a ductless or partially ducted system, which really cuts out a big piece of work on site for your construction crews, and also helps you cut costs significantly. Excuse me. There is a reason that these heat pump systems, whether it's ductless or partially ducted or a central air source heat pump system, we have the cost charted out here on the bottom right of the screen for all three of those. There's a reason that those aren't more popular today and that they haven't been in the past, and that's really the level of efficiency and especially cold climate performance. These used to be really only applicable to the southeastern United States, where you didn't have really rough cold winters. Cutting edge units today now perform down as low as -12 degrees Fahrenheit, which is a huge shift and really enables these to work in climates as cold as Chicago's. Mini splits in particular, beyond that ability to go with a ductless or partially ducted system, maximize the efficiency of a heat pump system. There was a carrier unit. I'm not sure whether or not it's on the market yet. It was announced several months ago that is rated at a SEER rating of 42, which is incredibly impressive. As far as I know, just a year or two ago, the best unit on the market was something like a 33 SEER. So there is a lot of progress being made here, and I think a lot of progress coming in the future. And then quickly, just a few barriers to think about here, especially if you're going with a ductless or partially ducted system. There are really some assumptions baked in here about your home layout, having a relatively open layout, potentially having ceiling fans. And just quickly, when we talk about the ductless system, you can see there is some cost for distribution. That we're using that to cover things like high transfer grills between rooms. In partially ducted systems, those could be actual ducts in the conditioned space, or something like a dropper or tray ceiling. There are a variety of different options here. And if you really want to dig into that, the DOE Zero Energy Ready Homes program has a lot of great information here. And then there's still concerns about cold climates. All the way up to Chicago, as long as you are designing your home well, these systems are going to work. Once you get into Minnesota and Montana, climate zone 6 and above, there are still some legitimate concerns about cold climate performance in the dead of winter. And then there is a commissioning concern here. Current generation heat pump systems have inverters, which add a commissioning requirement. That's potentially a new labor concern and a new pinch point. So something to be aware of. Moving ahead, I'm going to try to speed up just a little bit. So heat pump water heaters, another heat pump system. A lot of what I just said applies to these as well. Heat pump water heaters are 2 to 3 times as efficient as conventional electric heaters. They're again necessary for electrification. They're required for the DOE Zero Energy Ready Home certification if you're going electric. The DOE Zero Energy Ready Home certification does allow for natural gas options, but if you're going electric, it has to be a heat pump water heater. A couple other notes here. They're ideal for hot and humid climates because these actually cool and dehumidify the space that they're in. There's some considerations here. If you don't want that, you could potentially site your water heater in something like an unconditioned garage or a partially conditioned space. So there's a consideration here, but it could actually, in hot and humid climates, yield a benefit to your internal loads. For heat pump water heaters, just like we were just saying for heat pump HVAC systems, there are concerns about cold climate performance. This Northwest Energy Efficiency Association Tier 3 specification is something you can look up online really easily, and they do a great job of giving some performance specifications to ensure that, especially if you're in a colder climate like Chicago's, you're selecting a unit that is going to perform well and that isn't going to cause problems. And then a couple other barriers to note here. There have been some complaints from customers about noise in the past. These require a little bit more space than conventional water heaters. And again, there is a more complex commissioning process because you need to coordinate, an electrician and plumber on site as you're installing these. So a couple of complexities here for sure, but these were another thing that were recommended by our model in all 4 locations that we looked at. And then just lumping a few things together into easy win technologies. We're talking about Energy Star appliances, and that includes your cooking range, your refrigerator, your washer and dryer. Missing anything? Dishwasher. Water sense fixtures for all of your domestic water fixtures, and then LED lighting across the board. These are just absolute no-brainers. You can see here the chart at the bottom of the screen, the cost of all of these components. Again, that's the incremental cost compared to that IECC 2009 baseline and quote unquote average construction practices. That incremental cost, depending on your location, is going to be anywhere from $210 to $330, which frankly I was surprised by, having gone through school less than a decade ago and having learned some now very obsolete information about LED lighting. The cost for LEDs has really gotten already very close to fluorescent lighting systems, and the cost for Energy Star appliances and water sense fixtures is really just not that significant. There's not a very significant correlation between the efficiency of those systems and the added cost. So when you bring all these things in, you're increasing your upfront cost by $210 to $330. You're drastically reducing your internal loads, which means that you don't need as big of a PV system on the roof if you're going for net zero energy. It actually, varying by climate, allows you to reduce your PV system size by something like 1.5 to 2 kilowatts, which comes at a savings of $3,000 to $4,000. So obvious benefit here. These are just, I can't really imagine a situation. I mean, even if you're looking at multifamily or a colder climate, these are going to work. Really quickly, covering some envelope components. Just like everything else, we go into a lot more detail in our report, which you can download easily on our website. But I think really the summary here is we were frankly a little surprised that our cost optimization process didn't yield some more aggressive envelope components. And you can see here we're spending up to $2,800 on windows. The high end of that added cost is colder climates. That's going to be Chicago. We're looking at adding R5 continuous insulation to wall sheathing. That could potentially add another $2,000. Roof insulation, we're essentially going with 2012 or 2015 IECC code level. Slab insulation, we're not even going any further than the IECC 2009. So a little bit surprising here. I think this is influenced by the dropping cost of solar PV systems, but really the summary is envelope components, you can go relatively close to business as usual. And I'll give a little caveat there that there are reasons you might not want to do that. There are reasons you might want to push for passive house level envelope performance. Again, we're not looking at having the most comfortable building in the world here, although there are a lot of arguments that net zero buildings are generally more comfortable. We're looking at the absolute most cost-effective, cheapest way to reach zero energy. And what our models are telling us is that your envelope components can stay relatively close to code baselines. Finally, solar-ready roofing. This is a really important consideration, not just because it's required for the DOE Zero Energy Ready Home certification, which we're aligned with, but because especially if you're looking at doing zero energy ready and achieving zero energy later on, there are a variety of things you can be doing to make sure that that solar PV installation is going to be as cheap as humanly possible. And I'll leave that at that. NREL has a great report, which we've cited here, that goes into a lot of detail of what that means. And again, the Zero Energy Ready Home certification has a big checklist and a lot of guidelines that can help builders work with this. So let's jump to how we're looking at costs changing over time. And this is essentially the graph that Elisa showed at the very beginning of this presentation, juxtaposed against how we think things are going to look in 2030, 12 years from now. If we're looking at zero energy ready homes, that darker blue part of the bar, you can see we're really not expecting costs to change all that much. They're dropping by something like 10 to 15% in each location. In Houston, it's a little bit more than that. I can't recall exactly why that is, but the summary of that is these costs have more or less plateaued. Zero energy homes, on the other hand, costs are going to drop really significantly. In Houston, you can actually see we're expecting zero energy homes, that incremental cost to be more than cut in half by 2030. So let's jump into why exactly that is. The first and the biggest item is that solar PV costs are still declining. The cost for residential solar PV systems has been dropping by something like 7 to 10% a year for the last decade plus. This graph was created with some NREL projections, not even using the most aggressive end of those projections. We're really expecting costs to drop continuously till at least 2030. The complication here is the sunsetting of the investment tax credit, which consumers can currently use to cut the cost of their system by 30%. That will be phased out by the year 2022. So if you really follow the top of this lime green part of the graph, you can see what the net cost to a consumer is going to be. And you can see it wiggles a little bit. It increases from about 2019 to 2022. But overall, that line is actually staying relatively straight. And that net impact from 2017 to 2030, you're still dropping from something like $1.80 a watt to $1.40 a watt, which when you're putting thousands of dollars worth of solar panels on your roof is a pretty significant impact. Next, still talking about solar PV, but kind of indirectly, the other thing that we're seeing happen here is that the efficiency technologies that we're recommending the efficient technologies are getting more efficient. That's a terrible sentence, but moving forward. So we're not really expecting these technologies to drop in cost over time, but we are expecting them to become more efficient, which you'll see reduces your internal loads and thus reduces the amount of PV that you have to have on your roof. I believe this is for Chicago. Our current recommendations yield a PV system size of 8.4 kilowatts. With the more efficient technology that we're expecting to see by 2030, you're going to cut that system size by about 20%, which again, when you're putting thousands of dollars worth of solar panels on your roof, is significant. Finally, we are expecting to see some marginal cost reductions in a few pieces of these equipment. LEDs should reach cost parity with fluorescent lighting by 2030. We're expecting to see a drop in the installed cost of heat pump water heaters and ductless mini splits as these really emerge and start to take over the market. But you can see that rightmost column here, it's really dwarfed by the first two factors that we talked about. So with that, I will hand it back to Elisa to start talking about how we are getting these results into the market.
So yeah, as I mentioned before, we ended up modeling zero energy and zero energy ready homes in 4 different climate zones, and specifically in 4 different cities within those climate zones. And the reason we changed by climate zone is that the technical solution varies based on climate zone. So, for instance, in climate zone 5, you have a much more aggressive envelope than you would have in climate zone 3. But the cost also varies within those climate zones. So based on different utility rates, different local labor costs, baseline code assumptions, solar resource, solar cost, the cost is going to vary significantly. So what we did was we looked at we looked at kind of our results within those climate zones, made them national average, kind of readjusted the results to make them national average numbers, and then used different factors to adjust the utility rate and all these other factors that vary by location. As I mentioned before, the one thing we did not account for was local incentives. And so the result of that is within our appendix, we have tables that look like this for both zero energy and zero energy ready homes. And we took our results and we applied them to the 50 most populous cities in the U.S. And like I mentioned before, we didn't actually model in climate zone 1, 6, 7, or 8. But what was interesting was within the 50 most populous cities, only 3 of the cities actually fell within those climate zones. So that was a little bit of positive justification for our modeling approach, which was, I guess, good to see. But you can see within the zero energy ready homes cost, there's a significant variation in cost, where Philadelphia had the highest cost at about $7,600, and Austin had the lowest cost at about $1,200. With that being said, the general takeaway is zero energy ready homes consistently met the mortgage threshold, fairly consistently met the resale threshold, except for in Philadelphia, and consistently met that consumer willingness to pay threshold. Some of the reasons that one city might be better off than another could be they have a more aggressive code, maybe they have higher solar resource, maybe they have higher utility rates, and so the payback is better. So those are kind of the reasons for the variations. So what we really wanted to do, though, is along with this technical analysis with the numbers, we wanted to give policymakers and builders actionable next steps to help increase market penetration of zero energy homes. So now I'm going to pass it back off to Michael to walk through some of those recommendations.
Yeah, so like Elisa said, we obviously can't just give you all a bunch of numbers and expect everyone to know exactly what to do with it, right? So we're creating recommendations for builders as well, which we're about to get to, but also city policymakers so that they can start really promoting these homes in their locations. I'm going to gloss over this a little bit because we're starting to run low on time for questions, but you can imagine doing the analysis that we did. There's a fair amount of guidance that we can give on really which prescriptive incentives make most sense. And that's going to be things like those heat pump HVAC systems, heat pump water heaters, in cold climates, really efficient windows come on that list. Efficient appliances, water fixtures, and lighting, on the other hand, again, are already quite cost effective. There's an argument here that you don't need to incentivize them anymore. There's also an argument that people aren't necessarily going to do the most cost effective thing all the time, and that cities should still incentivize them, but cities can make that decision for themselves. And there are a variety of other items which are listed in a lot more detail in our report that we're giving recommendations, I guess, that we're giving to city policymakers. But we also just can't give city policymakers a bunch of numbers and a bunch of recommendations and expect them to know exactly what to do with it, right? So we're doing a little bit more than that. RMI has been working for the last, I guess it's been about 6 months now, with a cohort of city policymakers trying to take these recommendations and actually get them put into place. So we have 28 city members. That includes cities like New York City, Washington, D.C., Denver, Seattle, Phoenix, San Antonio. I'm sure there are a number that I'm missing. But we're working with all of these policymakers, holding a series of monthly workshops, giving individualized support, promoting collaboration between members. And even though, as you can imagine, the wheels of city government move relatively slowly, many of these folks are not expecting to implement policy supporting zero energy homes until 2019 or 2020. We're still showing an impact potential of 52,000 homes by the end of 2021, which might not sound like all that much when you think about the fact that there's something like 130 million homes in the US, but there are fewer than 14,000 zero energy homes on the market today. So if all 52,000 of those homes were made to be zero energy, that would be quintupling the market size of these homes. And that's really starting to get to that 10% market penetration where this starts to become a new normal, and not just large production builders, but smaller outfits across the country that can be clear on exactly how to do this, have a wide variety of case studies to work from, have local builders and contacts that know how to do this and have done it before, and really all of that is going to enable this market to take off. So let's look at recommendations for builders, because that's who you all are today, and that's why we're here. First, obviously, we want you to use this report to inform your future construction. Even if you've built a zero energy or zero energy ready home before, it's possible there's a cheaper way to do it. Second, we're really aligning again with the DOE Zero Energy Ready Homes program We think there are a wide variety of benefits to that program. There are things, I guess, a number of different kind of quality control measures like required checklists, require third-party energy rating, things like requiring solar-ready roofing, and then promoting collaboration between builders, providing a wide variety of case studies and other support, really helping you all see not just that this is easy to do, but really replicable, and that people all across the country are doing it. Third, it's important to find the right subcontractors because all of these recommendations fall apart if you are working with somebody that doesn't know how to do this and is going to charge, a 30% contingency fee because they're a little afraid of doing it wrong. There are not many subcontractors across the country that have a wide array of zero energy and zero energy ready home experience. As we said, they're only making up about 2% of the market right now. But there are folks all across the country, so this is an important piece if you're actually going to achieve the costs that are listed in our report. Fourth, honing your salesmanship. This isn't something we dig into too far in the report, but in the array of interviews that we held with zero energy home builders across the country, this really came through loud and clear that you can't just build it right and build it cheaply. You have to know how to tell a consumer about that. We had one builder tell us the last thing a consumer wants you to do is, open up the hood of your car and tell you exactly how it works. There's a lot of information out there. I think one item to point to there is the Build America Building Science Translator, which is one of the dozens of various resources provided on that DOE Zero Energy Ready Homes program landing page. Gives a lot of recommendations on really just salesmanship and figuring out how to ensure that not just home buyers, but also real estate agents and other stakeholders in the industry understand the benefit here and understand how to talk about it. And finally, we're working with local policymakers. We would love if you engaged with them. I think that is an important relationship to have to ensure that all parties here are moving forward appropriately, that we're making your lives easier, that we're achieving, city climate action goals, and making consumers happy. So with that, I think we can open it up for questions. We have a download link here that you can follow to download the report. It's about 50 pages. There's a whole lot of information in there that we didn't get to today. So please go take a look.
All right, thanks, Michael. Yeah, we've got plenty of time here for questions. I see some questions coming in, and start putting your questions there in the chat box, and we'll get to them in order. As those are coming in, huge thanks to all of our volunteers, our board of directors, and our top tier sponsors, T-Stud, thermally insulated, structurally sound wall stud assemblies, Shrinergy for on the go and in your home or small business backup solar powered battery solutions, and Mitsubishi Electric for getting to net zero with heat pump efficient systems. Big thanks to all of them, all of our sponsors. And real quick, for those of you also looking for ways to communicate and sell zero, the best thing you can do is try to obtain a zero energy designation or certification. So we have a zero energy ready, capable, and zero energy hero award you can check out on our website as a way to communicate your zero energy achievements, whether you're just getting ready for it, whether you've actually achieved it, or whether you've designed, built, and tested to get there, and it's real simple, just based on complete energy modeling. So with that, I definitely see some questions here, and the first one is kind of takes a real detailed dive here and just kind of asks, what qualifies as a high performance window? Is it Energy Star? Is it R5? What is that?
I am pulling up some information right now. The quickest way to answer that question is that we have very specific specifications listed in our report. Yeah, I'll leave it at that.
Well, and I'll also say it's definitely not an R5 window. We found that high performance double pane window actually would do the trick. We had aggressive triple pane windows as one of our potential solutions in the model, and typically the cost just wasn't there to make that pencil.
And just to give a specific example, in Chicago, we're looking at a U value of 0.29, so an R of something like 3.3, 3.5, solar heat gain coefficient of 0.56. So that's just a very specific example. We had something like 10 different window, 15 different window options in our model, and that's, for Chicago at least, what was spit out.
Yeah, well, and that, kind of brings up, I guess, a broader question that I had, and I just want to be clear that I heard you right. And basically what I had heard you say is that you were basically recommending for the thermal envelope performance to stick with the International Energy Construction Code, or known as IECC 2009. And so that's one question. And then adding to that question, I didn't see you mention anything about home size. And so does your recommendation still hold true for sticking to IECC 2009 when factoring in the size of a home, or do you have any comments on factoring in the size of the home?
Yeah, so that actually wasn't quite the recommendation. The recommendation was to do envelope improvements that were aligned with zero energy ready home requirements. And so that is, which is the DOE's program. So that typically actually aligns with IECC 2015 envelope requirements. So a little bit more aggressive than our 2009 baseline. And then for windows, they have more specific window properties within that zero energy ready homes program. So it is a little bit more aggressive than kind of the IECC 2009 code. Our prototype building that we modeled was 2,200 square feet, and that was determined based on kind of what a typical single-family home was being built, like kind of a typical average single-family home. That's the average size. Depending on the envelope, let's say you have a bigger home that has larger envelope, the economics might change. We didn't really factor in different sized homes, but I would say, I don't really see why having a bigger home would change the economics. Is there?
I mean, there are going to be different proportions of how much envelope you have per cubic foot of interior space. I think the summary for me is that when we're digging this deep, we really have to focus in on one particular building. We are planning on doing this.
Michael, we're kind of losing you there. Can you repeat that?
Sure. Yeah. Sorry. When we're digging this deep into the weeds, we really did have to focus in on one particular home type. We are giving an update to this report that'll look at a variety of different multifamily models, actually. But what I would say is, if you're building, an 800 or a 900 square foot tiny home, don't necessarily just take our recommendations at face value. I think there are a variety of resources that we list in that report. The biggest one I have in mind is, again, that DOE Zero Energy Ready Homes program. They have a Tour of Zero case study repository that you can look at and really get a great idea of using that, and their prescriptive recommendations and a variety of other resources. Get an idea of what the cost is and what the recommended design practices are for virtually any home you could come up with.
But I do think it is maybe worth calling out that the Zero Energy Ready Home program, they don't change their envelope recommendations based on size. So that seems somewhat promising.
Great, thanks. So, you did make it clear that you were just focused on the incremental savings and the energy efficiency aspects in solar, of course. But can you speak a little bit more to the fact that, these homes are getting tighter, and to build a zero energy home, it's got to probably be pretty tight. And at that point, you've got to start bringing in balanced ventilation. You really can't just get away with doing exhaust or supply only ventilation anymore. To keep your clients safe, right, and healthy. So, given that fact, can you speak a little bit to the idea that there's clearly energy penalties for balanced ventilation. So then you're starting to look at HRVs, ERVs, or CERVs, smart ventilation, and increasing costs through that. Can you speak to that at all a little bit?
Yeah, so again, an interesting takeaway of the analysis was that we didn't get to really aggressive, tight homes. Typically, the cost optimal solution was around 3 air changes per hour. So we did have ERVs and HRVs in the model, but they did not pencil, and this analysis just assumed just an exhaust fan, and because it was at that 3 air changes per hour, we thought that would be appropriate for that level of infiltration. Again, this analysis is very focused on cost. I think you could definitely make the case for ERVs or HRVs from an indoor air quality standpoint, but there's nothing that at that level of infiltration, or I guess air leakage, it wasn't required to include in the design.
Can you speak a little bit more, or is there any more details in your report about gut rehabs or even moderate renovations or weatherization projects? Or is that maybe a forthcoming report we can expect?
So that, yeah, it really wasn't the focus of this report. We wanted to really narrow in on new construction because, like I said, that's a really powerful intervention point. I think that doing renovations of existing buildings is obviously going to be needed if we're going to achieve our aggressive climate goals, and but the economics are definitely a little bit more difficult there, just because you have to account for the whole labor costs. You need to account for the full cost of the upgrade. I think one initiative that might be worth pointing towards is Realize, which is another initiative that's happening within Rocky Mountain Institute. And that's focused on retrofitting multifamily buildings to net zero energy. And it follows, if you're familiar with the energy sprung model from the Netherlands, essentially it's prefabricating upgrades off-site and then putting them on the property. And this helps reduce the overall time of the upgrade. And by doing an integrated design, it can lower the cost. It is focused on multifamily, and it's in the pilot phase, but I would say that's one solution for retrofits. I think in terms of single family homes, I think the only economics you don't get to benefit from incremental cost or labor cost reductions for new construction. But I think another thing that we've been working on is this zero over time approach, which is taking existing buildings and figuring out where is the appropriate trigger to upgrade a property at the most cost optimal time. So for instance, in a single family home, let's say your light bulb burns out and just like replace it with an LED. Let's say your appliances, you need a new appliance, then think about Energy Star. And so I would view it instead of doing a major renovation and doing it all at once, if you plan it out at the right time, you can kind of gradually get to zero energy and start seeing the economics closer to the economics that we outlined in this report.
Great, thanks.
Yeah, sorry, I was just gonna say for envelope, that's a little bit trickier.
Yeah, I think that single-family retrofits is really probably the toughest nut to crack, and the only area where we don't have an active initiative focused on that at RMI. We do a lot of work in the commercial space. As Elisa said, we've got multifamily retrofits. This is obviously single-family new construction. We're about to jump into multifamily new construction. I sure hope that we get to single-family retrofits after that, but it's certainly a difficult question.
Well, yeah, and I'm glad you brought up Energy Sprung, because we did a session with you all on that, so we do have that available on our website, and I know you all have that report. Multifamily, I'm glad you brought that up, because, multifamily, to my understanding and the way we see it shake out, is that on a per square foot basis tends to be significantly much more energy efficient than a single family home. And, I know as you get larger in multifamily, you start to really have more of a cooling load issue than a heating load, even on climate zone 6 in the cold weather climate states. So with that in mind, if a multifamily building is really just a single family home that's a box, multiplied by whatever number, I mean, a 4-unit multifamily home building, which is typically under most codes commercially defined as multifamily, but it could be smaller than a single family home. I mean, can't you just follow some of the same logic as you would, be putting out here in this single family home report?
I mean, so I would say two things. So at higher than 3 stories, that's when you start triggering that commercial code. So a kind of that home that you just outlined, the 4-unit home, that's still going to fall under the residential code. And it might follow similar recommendations. I think you kind of touched on the fact that multifamily tends to have lower energy consumption in general, and that's largely because they tend to be smaller units, and they also have a lot of adiabatic walls, so walls that don't look at the exterior, so you're not as dependent on the weather. And so I would say the solution, there are a lot of solutions that are applicable. So for instance, like Energy Star appliances, LED lights, low flow fixtures, those solutions are replicable and should be done in single family or multifamily. I think the HVAC solution is also probably replicable, and actually doing air source heat pumps or mini splits in smaller homes probably might make even more sense in multifamily. So one area that I would see probably the biggest shift is, you don't have as much exterior wall, and so potentially the answer might be different, and that's why we're actually doing an updated report that's going to be released in Q1 of 2019 that's focused on multifamily solutions, and just kind of and I think beyond just the technical solution variations, there's also very different consumer thresholds within multifamily, because about 90% of multifamily is rented, whereas a lot of single family is owner occupied. And so there's very different cost thresholds that need to be achieved in order to make zero energy economic in the multifamily sector.
Great, thanks, and hopefully we can have you back out for that one. On the heat pumps, I mentioned you brought it up, some of the issues there, and I wasn't sure if you in your study considered now, like Rheem has ducted heat pumps. So if you have those concerns about it, stealing energy from the inside, was that in your report at all?
No, it's a little bit difficult, because when we're trying to use, standardized cost sources, it becomes a little challenging to look at, specific manufacturers and specific units. We have to kind of use an amalgamation of things that are defined by our cost sources, which again were, not just the BOP software, but places like RS Means, NREL, NIST, the National Institute of Sciences and Technologies, had a great resource that we used. I believe we have heard good things about that Rheem unit, but getting into those specific manufacturers and products is something that we try to stay away from.
Got it. Fair enough. Well, we're a little over our time here, and I don't see any other questions. So I guess thank you all for doing this today. Thanks to Rocky Mountain Institute. Thank you all for joining us. And just real quick before we wrap up, where can people find more information, access this report if they want to learn more?
Yeah, it's that link on the screen right there. We'd love to have you all go download the report. Our contact information is made available in that report, and we'd love to have you reach out with any follow-up questions.
And I think also, if you don't want to read the full 50-page report, we are coming out with a bunch of blogs around this topic. So there was one that we came out with when we released the report. If you just go to RMI's blog, you'll keep seeing blogs coming out over the next few months.
And for those of you who kind of said you're struggling you couldn't read the link there, I don't know, just so you know, a real quick, easy way to find it is if you just type into a search bar, Rocky Mountain Institute, Economics, Zero Energy. It's typically the first hit that comes right up. You'll find it there. So I don't know if you have any other, short of reading off this entire link, any other ways to find it for the folks.
I'm just going to send a link in the chat box. I think that will work.
And we'll send one out through email to everybody else too. So, Michael, Alicia, I really appreciate your time today. Thanks for all that you do. We'll keep following up to see how things are going, and have a great rest of your week. Take care.
Yeah, thanks for organizing, Brett. Bye.
Yep.